So welcome back, learners. So today we will be moving on into the next topic, which we call it as simulation in R. So what does this simulation mean? So in simulation, so I said simulation. So you would have come across this term simulation. Fine. So simulation is something which you are going to simulate, which is not available actually, but you are going to try to simulate it. Fine. So for example, if you want to go for analyzing certain thing based on some 100 numbers, so you don't actually have 100 numbers with you. So in that case, what you have to do, you have to either create a file where you have some 100 numbers and then start your analysis. Instead of that, you can go for simulating or generating 100 numbers at random, and you can simulate that and try to analyze the scenario as well as the output. So for all these kinds of applications, we can go into the simulation. Fine. So our R console provides you with certain simulation based functions. So the very basic and the foremost function which we will be using for simulating is this rnorm. So we had seen this rnorm function in the previous session also. So I said simply that rnorm is a function which will help you to generate some random numbers. Fine. So actually this rnorm, we will be moving on into the detailed analysis of what this rnorm is doing. Fine. So yes. So what is this rnorm? So this rnorm is a function which will help you to generate random normal variates with a given mean and standard deviation. Fine. So if you want me to repeat it, it is just going to generate some random normal variates based on a mean and a standard deviation. Okay, fine. So usually all these, whichever I am going to discuss now in this session, so these methods and the functions are used mostly in your statistical analysis. So I will not be moving much into what are these functions and how they are evaluated and all. I will be just giving you that for this particular evaluation, you require this function. That's it. I will not be moving on into the mathematical concepts or statistical concepts. We will be just seeing which function could be used for which kind of statistical analysis. Okay, fine. So what is this rnorm? As I said already, you have rnorm function which can generate some random normal variates based on a given mean and a standard deviation. So this rnorm function has three arguments. So you say r, norm followed by a brace, a common brace. Then you will have the syntax will be the number, or I can say how many number of random normal variates you want to generate, and then the second argument will be the mean, the third argument will be the standard deviation. So this is the syntax of your rnorm function. Fine. Yes. So now by default this mean is considered to be 0 and standard deviation is taken as 1. So by default this is the value for this particular function. If you want to modify the value, you can very well modify. So as per these, out of these three arguments, this number argument, how many random variates you want to generate, that is a mandatory one, you have to specify. The remaining two are optional because by default it is having some value, that is 0 and 1. Based on that it will generate. If you want to modify the default value, then you can specify the second and the third argument. Fine. Fine. So now let's see an example with this. Suppose now I say I want to generate some 20 random numbers. Okay, so with mean 0 and standard deviation 1. So I say generate random 20 random normal variates. Fine. Yes. So now see, it is giving you. The next time again when I go for 20 again, so you can see the difference. See here the value is completely different. Here also the value is completely different. So each and every time when you try to go for generating these normal variates, you will get different values. See, you can see every time you can have different random normal variates generated. Okay, so these numbers are generated, these normal variates are generated having mean as 0 and standard deviation as 1. Suppose I want to change. you can change. Now I can say mean is 20 and standard deviation is 2. If you want to do this. So now see, I am not giving mean is equal to 20. I am just giving the value 20. Standard deviation is the third one, which is 2. Now you can see the difference. See, you have the different set of normal variates generated. Okay. You can even check out the second time. See the other one. And you can even modify this. Now I can say standard deviation is 3. Fine. You can say the mean is different. Suppose I say 30, you get a different one. Okay, fine. So this is the basic function which we'll be using in most of the applications, which is random normal variate generation, which is rnorm. Yes, we have the other two functions, the other three functions we can say. We call it as denorm, which is a variation of this rnorm. So what is this denorm? See, it is again normalization based. We say it is denorm. D stands for, see, you can just have this in mind. R stands for random. D stands for density. So what is this denorm? So it is probability density function. If you want to evaluate the probability density function at a particular point x, okay, then you can use this denorm. So what are the arguments of this denorm? So the first one, it has to be at the point x, what is going to be the probability density function. So I say x. Then you have again mean, the second one standard deviation, the third one. Apart from this, you have the other one which I call it as log. By default, this log value is false. Okay, and the mean value for this is by default 0. The standard deviation by default is 1. Similar to your rnorm function, but this is going to evaluate the probability density. So in this case, this x can be a single point or it can be a vector which has multiple points. Fine? Yes. So now if you want to check out with one example, so I can show you. Suppose I say at a point 10 denorm value. Fine. So what does this mean? This is a mean is 0, standard deviation is 1, and log by default it is false. Fine. You can see the same value. Now if suppose I change the log value as true, you will get a different value. See, we are not going to move into the actual evaluation part. It is just now, if you know how to go for evaluating a probability density function at a particular point, you can very well cross verify it. You will get the right answer. Okay. So this is with your denorm. Fine. You can change the mean, the standard deviation, everything. So this is denorm. So probability density function. Then the other variation of this particular denorm is your pnorm. So we call it pnorm. Fine. So this pnorm function, what it is going to do? It is going to evaluate the cumulative distribution of a normal distribution. Fine. So cumulative distribution for a normal distribution. That is what is pnorm. So again here you have some values. The first one, it says the value for which the normal distribution, for which the cumulative distribution has to be identified. Then you have the mean, again the standard deviation. Then you have the extra one which I call it as lower dot tail. Then again log dot p. Fine. So these are the arguments. So by default log dot p will be false. By default lower dot tail is going to be true. And for standard deviation by default it is 1, and mean is going to be by default 0. Okay. So this is going to be the syntax. So you say here this is by default. If you want to change these default values, you can give them. Otherwise mandatory you require this alone. Okay. Yes. So as I said, just the first one. Then you have the mean which is by default 0, standard deviation which is by default 1, lower dot tail which is going to be true by default, log dot p which is going to be false by default. Fine. Yes. So now just we will try executing one simple stuff. Now I say pnorm of 2. See, you're getting it. Now suppose I change this. Now if you want to check whether it is the default value, so what we saw lower dot tail is equal to true, then log dot p equal to false. So these are the default values. Fine, you have got. Now if you want to do it, suppose I say log dot p equal to true, see you're getting a different value. Now I say lower dot tail is equal to false, you're getting a different value. Now with this I'm going to change the mean as well as the standard deviation. Now I say 10 and 2, see you get a different value. Fine, yes. So this is with your p norm. So there is the other variation of this p norm, which is q norm. So q norm also has the same set of arguments as your p norm. So what is this q norm is? It is the reverse of p norm. So that is, it is going to give you the inverse cumulative distribution of your normal distribution. Fine, yes. So it is again p followed by mean, standard deviation, then lower dot tail, then again log dot p. Okay, so as I said for p norm, here q norm also you will have mean to be by default 0, standard deviation to be by default 1, lower dot tail to be by default true, then log dot p by default to be false. Fine, yes. So this is with your q norm. So these are the 4 usual functions which we'll be using in your simulation part in R. That is, you can simulate your numbers or the numerical environment, or for statistical analysis you can simulate the environment. Okay, fine. So apart from this, the most widely used one is this R-Poise. So what is this R-Poise? So R-Poise is going to generate the Poisson variates. Instead of going to generate normal variates, if you want to generate Poisson variates, then you can go with R-Poise function. So if you want to go for generating Poisson variates, what you will do? You will give the count. So you will give the count followed by the mean. Yes. So based on this, you can go for generating your R-Poise. Suppose I say 20 Poisson variates you want to generate with mean 2. See here, you have got generated. So now if suppose I say 20 Poisson variates with mean 30, see you are getting different values. Fine. So this is the other commonly used simulation function in R for your statistical analysis. So what we had seen here now 5 functions. So if you want, I can show them. So I say 5 functions. I am not going to clear the console. See, it is R norm we have seen. We have seen D norm. So R norm stands for, what is R norm? It stands for your random normal variate generation based on a mean and a standard deviation. D norm, which is for probability density function. Then P norm for cumulative distribution of a normal function, normal distribution. Then you have Q norm, which is the inverse cumulative distribution. Then we had seen the other one, which is R-Poise. That is Poisson variate, random Poisson variate generation. Okay, fine. Yes. So this is with your simulating environment in R. So this is how you can generate few random numbers. Either a normal variate or a Poisson variate or whatever you want, you can do it. Fine. So these are the 4 commonly used functions plus 1 which is for generating your Poisson. So 5 functions we have seen in this session. So you can work on with this, and if you have any doubts, you can very well contact me. Thank you.